Why haven't we implemented fusion nuclear energy yet? Ever wondered about that? Fusion nuclear energy, in its simplest definition, is the process by which two light atomic nuclei merge to create a heavier nucleus. This may sound a bit technical, but let's visualize it in a more relatable context. Picture the sun, a colossal, radiant sphere in the sky. The sun is actually a natural nuclear fusion reactor. Its immense energy, the warmth that nurtures life on our planet, is the result of countless fusion reactions happening every second. In these reactions, the sun's hydrogen atoms collide and fuse together, forming helium. This fusion process releases tremendous amounts of energy. Imagine harnessing that power for our use on Earth. It's an exciting prospect, isn't it? A virtually limitless, clean source of power that could revolutionize our energy systems. Now that we understand what fusion nuclear energy is, let's delve into why it's not yet a widespread source of power. Harnessing the power of the sun here on Earth sounds fantastic, doesn't it? So why haven't we done it yet? To answer that question, we need to understand the challenges fusion energy presents. Let's start with the conditions required for fusion reactions to occur. We're talking about temperatures in the region of millions of degrees and pressures that are immense, far beyond anything naturally occurring on Earth. Creating and maintaining these conditions is no easy task. Next, let's consider what's actually happening during fusion. At these extreme temperatures and pressures, matter exists in a state known as plasma. This isn't the plasma you find in a neon sign or a plasma screen television. This is a hot, charged gas made up of ions and electrons. Now you can probably guess that this plasma isn't something you can just put in a jar. It needs to be contained and controlled, and that's a huge challenge. The plasma in a fusion reactor is so hot that it can't touch any material surface, so it has to be held in place by magnetic fields. But controlling plasma with magnetic fields is like trying to hold a jelly with a rubber band. It's slippery, it's unstable, and it's constantly trying to escape. And let's not forget about the materials needed for a fusion reactor. They need to withstand these extreme conditions and also the intense radiation produced by the fusion reactions. We're still in the process of developing materials that can meet these demands. There's also the issue of safety and waste disposal. Although fusion is inherently safer than fission and produces less long-lived radioactive waste, there are still risks involved and waste that needs to be managed. In short, the challenges of fusion energy are enormous. They involve mastering conditions that don't naturally occur on our planet, controlling a state of matter that's inherently unstable, developing new materials that can withstand extreme conditions, and managing the safety and waste issues. These challenges make fusion energy a scientific dream, but not yet a practical reality. Despite these challenges, scientists are not giving up. Fusion energy holds too much promise. It's like a beacon on a hill, a tantalizing vision of a future where we harness the very energy that powers the stars. At the forefront of this quest is the International ITER project. This is not just a dream of a few starry-eyed scientists. No, this is a concerted effort by 35 nations, all pooling their resources, knowledge, and expertise to make fusion power a reality. The aim? To demonstrate the feasibility of fusion power. To show the world that this isn't just science fiction, but a tangible solution for our energy needs. ITER isn't alone in this pursuit. Around the globe, innovative approaches and technologies are being explored. In the United States, companies are investigating the use of high-temperature superconducting magnets. Magnets that could potentially contain and control the plasma needed for fusion. Across the Atlantic, in the United Kingdom, research is being conducted into laser ignition, a method that could kickstart the fusion process. But why all this effort? What's the big deal about fusion energy? Well, imagine a world with an almost limitless supply of energy. Fusion power could provide just that. The fuel for fusion is found in seawater and lithium, both abundant resources. And unlike fossil fuels, fusion doesn't produce harmful carbon emissions. It's a clean, green powerhouse. Of course, we're not there yet. These are still early days, but every step forward, every breakthrough brings us closer to a future powered by fusion. A future where our energy is clean, abundant, and sustainable. A future where the power of the stars is at our fingertips. So, while we may not have fusion power plants yet, the dream of harnessing the sun's power here on Earth is alive and well. Stay curious and keep exploring.